For the short way, Dr. Lottie would have us use Kb times the concentration of the base, and then we would raise that to the 1/2 power. And the reason why that ends up working is we can start out with a Rice table. So we're going to have our C2H5 3N, and since it has that nitrogen there at the end, you know that it can take on an extra hydrogen. If it's not NH4, it can always accept at least one more hydrogen. So then we're going to have that reacting with water, and so it'll take the hydrogen from the water. We're left with a hydroxide, and then we have the cation that's formed when that takes on the extra hydrogen. So now we need to set up our starting values. So originally you have a 0.010 molar solution. The water is a liquid, and so liquids and solids don't get used in our Rice tables. And then initially you have 0 for the concentration of your products. And then a certain amount of that will dissociate. And since it's all a 1-to-1 ratio, we end up with our equilibrium line being that minus x, and then we just have x and x. So that's our completed Rice table. And since that is at equilibrium, we are given our Kb value. So Kb, any of our Ks are always the stuff on the right over the stuff on the left. So we're going to have the hydroxide concentration times that cation, lots of letters here, all over the starting substance, our C2H5 3N. So we have the value for Kb. They told us that it was 5.3 times 10 to the -4th. And then we have X for OH, X for the positive ion, and then 0.010 minus X. And the value of X is going to be so much smaller than this 0.01 that at this point we can do what we call neglect the X. So we can say that this is basically equal to 5.3 times 10 to the -4th equal to X squared over 0.010. So we'll just do that Kb value times the 0.010, and that's going to get us 5.3 times 10 to the -6th is equal to X squared. So now we'll square root both sides, and we end up with X, which is the hydroxide concentration up here. So we end up with a value of X, which is equal to that. And we have 2.30 times 10 to the -3rd molar. So once we know the concentration of hydroxide, we can get the POH, because POH is the negative log of that hydroxide concentration. So we're going to do the negative log of the 2.30 times 10 to the -3rd, and that's going to give us a POH value of 2.64. And since we're solving for pH, pH and POH add up to equal 14. So we'll just do 14 minus that 2.64, and we get a value of 11.36 for that pH. And I don't know if your professor is big on sig figs or not, but when you're working with your Kb value, your concentrations, those were both 2 sig figs. And when you write pH and POH values, it's only places past the decimal that are considered sig figs. So that would be 2 sig figs for that one. And that is a basic value, which matches with our base that we have. So I hope that helps.